All right, so today we're going to do 4.2. So today we're going to continue the story. A removable discontinuity is a hole in the graph. So let me explain how you find the hole in the graph. So step one is you're going to factor the numerator and denominator. Okay, factor the numerator and denominator. Step two, cancel any common factors. Step three, set the common factor equal to 0. And when you solve for x, that's the x coordinate of the hole. Then plug x into reduced answer, and that's y, the actual y value. All right, so in example 1, we're going to factor, cancel common factors, and find the removable discontinuities. So it's been partially factored. All right, so there's a common factor of x minus 2. So this is reduces to x minus 1, x plus 3. So that's my reduced answer. So then to find the removable discontinuity, I canceled x minus 2. So you take your canceled factor and set it equal to 0. Then you plug that into the reduced answer. That's 1 times 5 is 5. So the removable discontinuity or hole is 2, 5. All right, let's do it again in letter B. Go ahead and pause it and see if you can't get it before me. So I factor the numerator and I factor the denominator. You cancel your common factor of x plus 6, and you get 4 over x minus 2. So the removable discontinuity is going to happen at x plus 6. So that's x equals negative 6. I plug in negative 6 minus 2. That's negative 1/2. So the removable discontinuity is negative 6, negative 1/2. All right, now we're going to put it all together. When you are asked to graph, it is assumed you're going to do all these things, and I'm going to help you by creating a table of values and a table with the indicated information. So what I do is I just look at my rational function and I just start factoring. So the numerator factors into x plus 2, x minus 2. I can cancel the common factor. Wrong spot. I'm going to cancel the x plus 2, and that's going to leave me x minus 1, or excuse me, x minus 2. So I have a removable discontinuity that's going to happen at x plus 2, and I plug that into the negative x minus 2, so it's negative 4. So the hole is at negative 2, negative 4. All right, to refresh your memory, in x-intercept, you let y be 0. So if I let y be 0, x is 2. To find a y-intercept, you let x be 0. So the y-intercept is 0, negative 2. In this case, there's no vertical asymptote, no horizontal asymptote, and no slant asymptote. We'll come back to domain and range when we're done. Now do me a favor, when you make your graphs, at least indicate on the x and y axis your scale. They're not always ones, which we're going to see on the next graph. All right, and in this one, I don't really need any additional points because it's just a line. So let's plot 2, 0, 0, negative 2, and then I have a hole. Remember, there was a hole at negative 2, negative 4. So I'm going to make a hole there. All right, then the domain. This is going to be something interesting. This might be new notations for us. It's X, and it looks like a funny shaped E, is an element of, and I'm going to use a capital R with a double line through it, which stands for is the set of real numbers. And the only X value we don't have is at the whole. So X is not equal to -2. The range, Y, is the set of all real numbers. Y is an element in the set of real numbers such that Y does not equal to, and it's -4. All right, so this one was a very, very basic one to get started. Will your graphing calculator be so kind as to show you the removable discontinuity? Why don't you pause and go put it in your graphing calculator, and you're going to find out, nope, it does not. So you have to be smarter than that calculator. All right, so let's look at example 3 together. It says graph f of x equals 2x squared minus 12x plus 16 over x squared minus x minus 12. All right, so your first step is let's start factoring. And I do assume that you know how to factor. If that's bad on my part, you need to let me know that you need some help with factoring. But at this point, we should be pretty good at it. So when I completely factor that numerator and denominator, hey, I've got a common factor. So that simplifies to 2 times x minus 2 over x plus 3. So I'm going to whole at, I said x minus 4 equal to 0, so x is 4. And then I'm going to plug that into the reduced answer. So 2 times 2 is 4, 4 plus 3 is 7. So I actually have a hole in the graph at 4, 4/7. Okay, so let's look at the reduced answer right here. That's 2x minus 4 over x plus 3. So I do have a vertical asymptote of x equals -3. I have a horizontal asymptote at y equals 2, and there is no slant asymptote. Let's find the x and y intercept. Now stop and think on this one. My reduced answer is a fraction. The only way a fraction equals 0 is when the numerator is 0. So to find your x-intercept, you set the numerator equal to 0. So x is just 2. The y-intercept is still the same. It's 0, and that's -4/3. So I'll come back around to domain and range when I'm done. But something I need to tell you about, and this is for me personally, as me as your teacher. When you graph a rational function with a vertical asymptote, I require 3 points left and right of the vertical asymptote. Okay, that's not an IB requirement, that's a Mrs. McInerney requirement. So here's what I mean. If the vertical asymptote is x equals -3, I'm going to go -4, x is -5, x is -6. That's 3 x values to the left of x equals -3. Then I'm going to get 3 to the right. So that would be -2, -1, 0. Now typically at least one of these points would be a hole or an intercept. So I do have 0, -4/3. So I've got that one. Now go ahead and pause the video and find your other ones. All right, so hopefully you paused and got those values. Now, on the x-axis, I can still go by ones. So remember what I said? You need to make a tick mark that lets me know your scale. because they're not always 1, so don't assume that. So go somewhere and let me know on the x-axis what your tick marks are. On the y-axis, I cannot get 12 to -8 by going by 1s. So I'm going to go by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So let me plot. I always start with my vertical horizontal asymptote and the hole in the graph. Now be careful, since it's y equals 2 and my y-axis is going by 2s, it's the first tick on the y-axis. All right, and then I had a hole at 4 and 4/7, so you are going to eyeball that. Then I have 0, -4/3, -1, -3. So you got to remember, oops, that's not a hole. You're going by 2s there. -2, -8. And make sure your hole in the graph looks like a hole. Don't draw the line through it, because then that'll look like it's connected. Then I have -4, 12. -5, 7, so 2, 4, 6, and halfway between 6 and 8. That was -5, 7, -6, 5.3, so 2, 4, there we go. And then what should happen is your graph should hug the asymptotes. All right, now I like to do my domain and range when I'm done. So x is an element of the set of real numbers such that x does not equal -3 and it doesn't equal 4. Okay, it doesn't equal -3 because that's a vertical asymptote. And it doesn't equal 4 because that's a hole. And you can get that restriction right here in the original problem. Then the range, y does not equal 2, but it also never equals 4/7. All right, good job, good job, good job. Okay, very interesting stuff. All right, then our last example, if f of x equals x minus 4 over 3x minus 2, find f inverse of x. So if you want, I put something funsies in here with a QR code. So to find an inverse, we switch x and y, then solve for new y. That'll give you your inverse. All right, so you did inverses in Algebra 2, and if you took pre-calc, you did it in pre-calc. So watch what you're going to do. You switch the x and the y, and now I'm going to solve for new y. So you need to clear the fraction, so we multiply both sides by the denominator. And then here's the big idea. We're trying to get y alone. So I need to move it onto one side. So I typically will move mine to the left side, and then I'll add the 2x to the right. Then I'm going to use factoring, and I'm going to factor out y, because I can't combine them right now. 3xy minus y, those are not like terms. So and then watch what we're going to do. This new y is the inverse, so let's tidy that up and call it f inverse. So f inverse is 2x minus 4 over 3x minus 1. All right, that's the end.